1844, a group of fishermen rowed out into the freezing waters of the North Atlantic. Their destination was Eldey, a giant sea stack 13 miles off the southwest coast of Iceland. They were risking their lives, driven to find a seabird so rare that a single specimen would raise a small fortune.
No.
Clumsy and flightless, once they spotted it, the bird was doomed. The creature they'd killed was called the Great Auk. This was the last confirmed sighting of the species, even though people went on searching for decades. Ironically, the Great Auk had been killed for the very people who most wanted to save it. For millions of years, the North Atlantic was home to one of the most remarkable seabirds ever, the Great Auk. A mere 250 years ago, you could see thousands of them in vast colonies. Now, they're all gone. Today, the only great auks that remain gather dust in Victorian museum collections. Just 80 specimens, all dead, stuffed. They date from the 19th century, when the Great Auk captured the public imagination. Its eggs changed hands for huge sums of money. It even became a brand name. Yet, despite the Victorian fascination with it, the bird was a mystery. Scientists were ignorant of how many there were, where it lived, or how it had evolved, until it was too late. Even the penguin-like appearance of the Great Auk is deceptive. Ornithologist Errol Fuller has studied and collated every stuffed museum specimen known to exist.
The Great Auk is a very interesting example of convergent evolution. It looks very much like a penguin, but in fact it isn't. It's not related to the penguins at all. It's related to the birds that we call now guillemots, razorbills, even puffins. That's where its affinities lie. But it happens to look very much like a penguin because it lived very much the same kind of life.
The auk was larger than the average penguin, and it was a far superior killer. No penguin ever evolved such an effective weapon. A beak, long, sleek, and sharp enough to slice through prey in a single bite. And to chase its victims underwater, it was more agile than the penguin.
At the top of the bird, the beak is compressed so that that doesn't offer much water resistance. Then the bird is generally beautifully streamlined. This bird would have been superbly sleek and hydrodynamic with very small wings so that they don't resist against the pull of the water. And when we get to down towards the bottom, the feet are thrown very far back. All those things conspire to make this bird like a torpedo in the water.
Guillemots and razorbills may be the auk's closest living relatives, but there's a crucial difference between them.
This guillemot has very long wings, and that tells us immediately that this is a bird of flight. The wings on the Great Auk are really very, very short, and you see that they couldn't possibly have enabled a bird of this size to take to the air.
The auk and the guillemot were most alike not in the air, but under the water. For biologist Donald Kroll, guillemots and auks stand comparison with the ocean's most magnificent creatures.
We think of sperm whales as being these amazing long-duration divers, and elephant seals, long-duration deep divers. But if you scale it to their body size, you're talking about an animal that weighs thousands of kilos versus a bird that weighs 1 kilo. So pound for pound, what these birds are doing is just absolutely astounding. They're the deepest and longest diving animals that have ever existed on Earth. And so pound for pound, the Great Auk might have even been a better diver.
The auk's much reduced flipper-like wings now had less surface area, enabling the bird to power through water that's many times denser than air. But to dive so deep, it had paid a price.
What these birds did is essentially, in an evolutionary sense, make the great sacrifice. They gave up the ability to fly in order to become the supreme divers, if you will. And so the Great Auks were probably one of the best northern hemisphere divers that existed. And so it really was quite an amazing evolutionary transition.
All this happened to make the Great Auk a devastating underwater predator. For over 10 months of the year, the auk lived entirely in the open ocean, hunting schooling fish like capelin. But the flightlessness that made the Great Auk such a successful underwater hunter also made it uniquely vulnerable. On land, the bird was clumsy and highly at risk from any predator that could get near it. Its only defense was to live as far away from predators as possible, and that wasn't easy.
You going to mug me?
Am I going to mug you?
Is that gorgeous or what, eh?
And I believe I can run a decent marathon.
Thank you very much.
Download Veely now.
Great Auk, of course, was the northern hemisphere's last flightless seabird, and their flightlessness made them vulnerable on a number of levels. One is that they had to breed in areas where they could come ashore without having to fly ashore, so they had to be able to come ashore in some place where there was a beach, and that kind of limited where they could breed.
There were precious few places the flightless Great Auk could have gone. Cliffs and rocky coastlines would have been out of their reach. 40 miles off Newfoundland, on the eastern coast of Canada, lie the Grand Banks. An area of shallows, with an archipelago of tiny islands and drifting icebergs close to where the Titanic went down. For millions of years, this was the auk's stronghold. Ecologist Bill Montevecchia searches for traces of the bird he knows he'll never find alive among the islands.
You know, there's always been a bit of mystery about these birds and about these islands. I still look for them, you know. I mean, I know they're not there. I still look for them, right? I mean, because of that sort of presence of them having been here. Look at these islands here. They're flat. They're just like pancakes. And this is a perfect island for a flightless bird. This is the kind of island that Great Auk had to have.
Isolated and uninhabited, the auk lived here and nowhere else along the North American coast, undisturbed for millennia. But 500 years ago, it suddenly came under attack.
In here is a skull of a Great Auk that I dug on Funk Island. This is the beak. Quite incredible, powerful beak. This was all one piece that actually subsequently fragmented. There's a few cracks in the cranium of the bird here. It might have been where it was banged over the head.
Out here, only one predator could have done this: man. In the 16th century, explorers set off from all over Europe to cross the Atlantic in search of the New World. Frenchman Jacques Cartier was one of them. After sailing for months across the uncharted ocean in search of the Northwest Passage, his ship came across these islands. For the half-starved crew, what they found here proved a godsend.
The crews are stressed for protein, for food, 6 to 8 week crossings of an Atlantic Ocean that's tough. You don't have a refrigerator. You've got dried meat, you've got salted meat, and you're lucky to be alive by the time you get to this side. So Cartier's sailing over here, up on the northeast coast, he finds this flat island covered with flightless birds. I mean, he couldn't have hit anything any better. For centuries, you know, this flat island really was first fast food takeout in North America.
Hunted for food, the Great Auk suddenly turned from predator to prey. Yet its extinction is no open and shut case. Ultimately, was man the scientist more to blame than man the hunter? The Great Auk was the only flightless seabird ever to exist in the Northern Hemisphere. 500 years ago, the flat islands off the coast of Newfoundland would have been covered with millions of them. Ecologist Bill Montevecchia knows that it had taken to the water so completely, only one thing brought the Great Auk to land: sex.
If they didn't have to, great auks would never come to islands. And what compels them to come there is because they have to lay their eggs on solid land. It's also where they meet their mates and copulate and produce that egg in the first instance.
For many seabirds, the huge population density of the colony is necessary for successful reproduction. Like guillemots, auks may well have paired for life. As this female's breeding partner approaches, she wobbles and gurgles to greet him. He taps his beak against hers, and they preen each other. They'll incubate the egg for about 40 days, taking turns to keep it warm while the other one looks for food. The swap over is a painstaking business and can be perilous. But not as perilous as what was about to happen. With the arrival of hungry sailors, the Great Auk had to cope with a threat that evolution had not prepared it for. Flightless and unable to escape, they made easy pickings. Thousands were slaughtered summer after summer. Yet killing auks for food was only the beginning of the end.
We don't think that's why there are no great auks here today. We think it was a systematic killing that occurred in the 1700s when crews of men went there to live there, to stay there, to slaughter these birds for a very specific reason.
That reason was fashion. 200 years after Europeans first arrived, the killing changed gear as hunters switched their attention from food to feathers. Auk feathers were sold to make mattresses and even became fashionable in ladies' hats. Thousands of birds were captured, killed, and dumped into cauldrons, where they were boiled just long enough to make their feathers easy to pluck. In the thin covering of soil on the islands, Bill has uncovered physical evidence of the carnage.
Got some metal pieces and plates that were pieces of cauldrons that perhaps were used to parboil the birds to get to the down underneath the waterproof feathers. Also, this hook, which I presume was a hook that would have, maybe held the cauldron over a fire where the birds could have been parboiled. The oily, fatty birds were used as the fuel to keep the fires burning, and you can actually find these pieces of charcoal, and if you look really carefully you can see where the feather shafts of the birds were. It was that real systematic overkilling of the animals.
In 1785, Captain George Cartwright, adventurer and trapper, observed,
"It has been customary of late years for crews of men to live all summer on the island for the sole purpose of killing birds for the sake of their feathers. The destruction which they have made is incredible. If a stop is not soon put to that practice, the whole breed will be diminished to almost nothing.
And that's exactly what happened. By the 19th century, the vast colonies on the islands off Newfoundland had been completely destroyed. But the species survived. There was still hope. Across the Atlantic was one other refuge.
The last great auks off the fishing banks of Newfoundland were seen in the mid-19th century, but really the species had ceased to breed there, and the only remaining breeding colony of the great auk in the whole world was on a tiny island off the southwestern tip of Iceland. But it was about 26 miles from the mainland, so it was a dangerous procedure to go out there.
Isolated from the threat of man, in Iceland it seemed the great auk had finally found a safe haven. And for hundreds of years, Icelandic folklore even helped protect this colony from humans, who were too scared to go there.
This little island was invested with quite fearful stories. People had died going out there in the 1620s. There were stories going back to the 14th century of somebody who lived there and survived a winter, refused to tell anybody how he'd survived. So the story grew up that he'd been looked after by the Hildefolk, who were these fairies and ghosts.
These haunted islands protected the birds, but then nature, not man, dealt them another blow. In March 1830, an undersea volcano erupted. The auk's refuge exploded and disappeared beneath the waves. But even the hand of nature couldn't drive the auk to total extinction. About 40 pairs survived the eruption.
The birds had one other place that they could breed on, which they never had bred on, because it was 13 kilometers nearer to the mainland and not ideally suitable. But this was the one that they chose after 1830. The bird really didn't have much chance of survival once it had chosen a breeding site that was so near to the mainland.
This last haven was Eldey, and the auk sought refuge here just as scientific interest and sympathy for its plight was growing. Yet at this time, the study of natural history meant collecting and classifying, pickling, preserving, and stuffing. The rarer the auk became, the more sought after it was.
This was the golden era of natural history collecting, when every gentleman worth his salt would feel the need to put together a large collection of natural history items, stuffed animals, stuffed birds, birds' eggs, and at the same time the great institutional museums of the world were becoming interested in natural history specimens. So the great auk, of course, in its declining years, corresponded with just these years when this great surge in natural history collecting was taking place.
But in their enthusiasm for collecting, Victorian scientists neglected animal behavior and failed to understand that with the loss of the auk's breeding colonies, it was already on the very brink of extinction.
Once the numbers fell below a certain level, even though that level may have been quite considerable, the bird was doomed. And we can almost test that, because if this had been a bird that could have lived in 3s and 4s, 6s and 7s, 10s and 12s, it would still be among us today, because it could have always found little lonely coves, lonely islands in the North Atlantic where just a few individuals could live. The fact that we don't find it today is proof, surely, of the fact that this was a bird that could only live in colonies of large numbers.
This was a fatal misunderstanding, because now, in their ignorance, Victorian scientists unwittingly pushed the great auk to its final extinction. On Eldey in 1844, the hunting trip was undertaken at the request of a keen Danish collector of rare birds and their eggs, Carl Siemsen. One of dozens of dealers across Europe, he believed he was furthering the cause of scientific knowledge, as well as making a handsome profit.
Birds like this one, and all the ones we see in museums, almost without exception, were caught on the island of Eldey. They were caught by Icelandic fishermen who landed on the island with a certain amount of difficulty, actually approached the bird, grabbed it because it was so helpless on land, unlike in the water, probably wrung its neck there and then on LD, took it back to their fishing village, skinned it, ate the body, and then sold the skin for comparatively small amounts to traders in Reykjavik, who then sold them on to museums in Europe.
By 1844, far from providing a refuge, LD was more like a prison, where the last remaining breeding pair of auks awaited the inevitable. Even then, no one realized that the Great Auk was now extinct. It was confidently asserted that colonies thrived even further north in Arctic waters. Scientific interest continued unabated.
It wasn't perhaps till a decade after the Great Auk actually became extinct that scientists went to Iceland seriously looking for it. And by then, of course, it was too late for them to find it.
As the years went by, the very scarcity of the bird only managed to increase demand for dead specimens, driving prices higher and higher.
It started off at amounts like £5, £10, but by say 1870 you'd have got £40 for a Great Auk. By 1900 you'd have got £350 for a Great Auk. Now £350 was a huge sum of money at that time. Just to put it into context, you'd have probably been able to buy 3 or 4 houses with that amount of money.
Auk mania ensured the bird was never more famous than the moment of its extinction. In the 1880s, novelist Charles Kingsley caricatured the bird standing on the All Alone stone in his children's classic, The Water Babies. The Great Auk had become a mythical creature, but the opportunity to experience it for real had been lost forever. After 100,000 years, the Ice Age is coming to an end. This treeless grassland is the domain of a spectacular creature. A creature which ranged across Europe from the French Pyrenees to the Russian steppes, but in Ireland it found a homeland which human hunters had not reached. It has antlers so vast and elaborate, they stretch 12 feet from tip to tip. They are the crowning glory of the magnificent Irish elk. But this giant deer has presented science with an intractable mystery. Why, having flourished for millennia, did it undergo catastrophic extinction? Were its massive antlers to blame?
The Irish elk has a sort of iconic status among Irish biologists, and it seems to me that it's a great animal to study the great themes of evolution. For example, how did it get to be as it is? And in this particular case, how did it die?
A disused army barracks in the heart of Dublin is the final resting place for prehistoric remains which have been excavated over the last 200 years. Paleontologist Tom Hayden has come to take a closer look. Stored here are the peat-blackened remains of hundreds of Irish elk, which died between 10 and 15,000 years ago. The stag's skulls are extraordinary, boasting the largest antlers of any deer that has ever existed.
This is what all the fuss has been about. A male Irish elk. This animal had antlers which weighed about 40 kilos and measured, in large specimens, 12 feet from end to end. I could stretch myself along the antlers from one tip to the other twice.
No modern animal comes close. To find out how it coped with such a massive burden, Tom needs to examine a fully assembled skeleton. It's clear that the Irish elk had specialized, evolving a physique capable of supporting its vast antlers.
There's a massive rib cage. And this, in life, of course, supported a very large heart and very large lungs. And this is what we would expect for an animal that had a lifestyle like the giant deer. An open plains runner, probably high stamina, and this essentially is typical of an aerobic machine. And now we come to the more spectacular end of the animal, where we find the antlers. And quite apart from being extremely heavy, they're also extremely awkward, because a lot of the weight is a long way away from the center of the animal's body. So it's like holding very large buckets at arm's length and trying to maneuver them. It puts a lot of torsion and stresses on its neck. And for that reason, the vertebrae in its neck are very large, quite strong, to try and cope with the stresses and strains of moving this great weight about. Behind the neck, the spines and the vertebrae are very, very tall. And in life, these would have acted as anchor points for a system of cables, ligaments, which ran from here to the neck and helped the animal to raise it and move it around.
Antlers place a further demand on a deer. It must shed and regrow them each year. So how did the Irish elk fuel the growth of their unusually massive antlers? What did they eat? Tom Hayden is looking for clues amongst the teeth of a mature stag skull.
These white enamel ridges have very, very fine scratches, and there is only one substance we know about which will produce these scratches, and that is grass. Grass has silica particles in between the cells which act like sandpaper as far as the teeth are concerned. And if you look at the enamel on a giant deer and compare it to the enamel on a cow, they're identical. So this is strong evidence to suggest that they ate mainly grass.
Pollen samples reveal late Ice Age Ireland was an open, treeless landscape. Its abundant grasslands rich in nutrients like calcium. A perfect environment for the bulk grass feeding the Irish elk's antlers require. Back in the 19th century, Charles Darwin's detractors seized upon these antlers to attack his heretical theory of natural selection. If the survival of the fittest really designed animals to survive, what possible advantage could such an extravagant burden provide? They used the Irish elk to cast doubt on Darwin's theory. To this day, researchers continue to question how natural selection could have produced such large antlers. Why invest so much in them? What was their purpose? Paleontologist Adrian Lister believes that today's fallow deer can provide vital clues.
The bucks have got their antlers about half grown, but you can already see the way the antlers grow horizontally out from the head, just like in the Irish elk. There they go.
He's conducted anatomical studies that have thrown up a surprising result. They reveal the tiny fallow deer is a distant cousin of the Irish elk.
The Irish elk has got particularly strongly developed neck vertebrae, which were to hold up the very heavy head with the weight of the antlers. And the fallow deer, if we look at the neck vertebrae, have got the same structures, although of course they haven't got such heavy antlers now. They've got the similar structure, and that proves the relationship.
But can the fallow deer provide an insight into how Irish elk stags use their vast antlers? Sex may provide the answer. Fallow deer have a mating system called lekking, in which females move among the stags and choose their mate on the merits of his antlers.
In the fallow deer, the male will do a kind of display, moving his head from side to side, and he's got these flattened palmations of the antlers which will be shown off in that way to the female who's following on behind him. With the Irish elk, with the flattened parts going straight out horizontally like that, and also being so large, maybe the animal didn't have to do that kind of behaviour. Just standing there would have been impressive enough. If the female was interested enough, then mating would ensue.
The huge palms of the stag's antlers flash like mirrors across the open landscape, attracting a female willing to mate. For females, the choice is simple because, for them, bigger antlers indicate a fitter male. So the genes of large antlered males were continually passed on. Sexual selection was driving the development of these enormous antlers. For over 100 years, scientists denied the antlers could have any other role. Now biomechanics expert Andrew Kitchener can prove they were also deadly weapons.
What my research has shown is that the antlers are not just designed for display. There's too much material in here to just be used as an elaborate advertisement hoarding. They're designed for fighting, both at the structural level as to how they actually fit together, and also at the mechanical level. They are actually strong enough to take the massive forces that would have been produced in fighting.
The highest density of bone occurs where the antlers impact and lock together. From his observations of other deer, Andrew has demonstrated how these points, known as tines, could be used for defense and attack. In the mating season, stags challenge each other for the right to mate. At first, the stags size each other up. But what would happen if battle commenced?
The next stage would be to twist the head right round, drop it down to the ground so that the nose points back between the front legs. And now you can see the different parts of the antler coming into function for fighting. Here we have the brow tines and also the secondary tines, which act in a defensive way. They protect the head and the eye from accidental injury if the antlers were to slip against each other. And on the outside, on the palms here, we have these very long offensive tines which point in towards the neck and the flank of the opponent. And during fighting, the aim is to try and wrestle your opponent off balance and hopefully knock him over so that you can use these tines to actually stab your opponent in the flank or the neck.
Andrew's research reveals stag fights would have been brutal and violent. This stag has proved he is the alpha male and secured his access to the females. In attracting a mate and fighting off rivals, the antlers were the key to passing on an individual stag's genes. But could this design have also brought the Irish elk's downfall? Carbon dating of the Dublin bones reveals that 10,500 years ago it vanished from Ireland. Why, just as the Ice Age was ending and conditions improved, did the Irish elk face extinction? "11,000 years ago, the Ice Age was coming to an end. Rising global temperatures pushed back the icy tundra that had stretched across northern Europe. In Ireland, the Irish elk, a giant deer with vast antlers, had evolved to graze the rich Ice Age grassland. Irish elk were once plentiful. Over 100 individuals have been excavated from one peat bog alone. But around 10,600 years ago, the fossil record reveals the Irish elk disappeared suddenly and completely. What caused this catastrophic decline? Geologist Pete Coxon is trying to find out. He's investigating what happened to the local climate in Ireland at the end of the Ice Age. Almost 3 meters below the surface, he finds soil which dates back 11,000 years to the late Ice Age, when the Irish elk was still thriving. These late Ice Age soils are rich in pollen. They show it was cooler than today, but there was abundant grassland.
You can see organic sediment being laid down with seeds and bits of leaf and so on. And in this core we can even pick out fragments of plant, fossils of plant. There's some cuticle there of a grass or a sedge.
When Pete takes a sample from slightly higher up and 400 years later, the very end of the Ice Age, there's a dramatic change. The grass pollen has been replaced by eroded rock and sand. For Pete, it's evidence of an unexpected climate change that wiped out vegetation.
We see in this section this very sudden cold snap. You see sand and inorganic material in here. You get a lot of erosion, a lot of movement of soil down the slope, and that's why we see these inorganic sediments. And this cold snap lasted 1,000 years. Temperatures 7 degrees colder than the present day. Suddenly, the biological productivity plummets.
Ironically, as the rest of the world warmed up at the end of the Ice Age, Ireland was hit locally by severe cold. It seems to defy logic. But the sea provides an answer. As rising temperatures melted the great polar ice caps, cold water flooded into the Atlantic Ocean, cooling it by an estimated 8 degrees Celsius. Warm Gulf Stream currents flowing up from the tropics were blocked. Ireland lost its central heating and was plunged into freezing conditions. In a severe cold period, stags with smaller antlers, less of a burden, would have had a better chance of surviving. Natural selection would predict they would now be the fittest. But is there any evidence that the Irish elk evolved to become smaller? Tom Hayden has measured hundreds of antlers from this crucial period. But he can't find any indication that they were shrinking. Ironically, sexual instinct may have outweighed survival instinct.
The Irish elk was caught in a dilemma, in a sense. It was being forced in one direction to maintain large size and large antlers at a very expensive cost by sexual selection. And on the other hand, natural selection would have been dictating a downsizing, a smaller animal, smaller antlers, a less expensive lifestyle. Unfortunately, it couldn't make that transition.
In the grip of sudden climate change, it appears the Irish elk could not evolve quickly enough. Ten and a half thousand years ago, the Irish elk succumbed to extinction. For scientists, that's long been the end of the story. But bones stored here are adding a new twist to the case of the Irish elk. They're not from Ireland, they're from the Isle of Man, which was then connected to Britain by a land bridge. In 2000, Adrian Lister started to carbon date Irish elk remains from northern Britain. The result from the Manx skeleton was a bombshell.
We've got the radiocarbon dates back from the lab, and amazingly, they show that this Irish elk skull is the latest one that we have from anywhere in the world. This specimen is only 9,200 years old. And so this specimen shows that the species did actually survive for nearly 1,500 years longer than we'd previously imagined.
The question is, why? Ireland's cold spell had been severe but local. To the east of Ireland, the Isle of Man and southern Scotland were more sheltered, and Irish elk here must have been able to cling on for another 1,500 years. Yet these late dates mean that the remaining Irish elk may have encountered a new threat. At Edinburgh University, archaeologists are sifting through the debris from a human encampment. Clear evidence that late Stone Age hunters had reached southern Scotland at the same time as the remaining Irish elk were escaping the cold. Did they hunt them down? Intrigued by this possibility, Adrian Lister goes to examine the Edinburgh evidence to search for signs that man hunted the remaining Irish elk.
There's a deer tooth, that's a red deer upper molar. That's a deer humerus, forearm bone. That's red deer size. That's a little bit of the bottom end of a so-called cannon bone, which is the lower leg bone. Again, that's red deer. There's a clear impression here that red deer is the dominant prey animal.
There are plenty of deer bones, but no sign of Irish elk at this site. No hard evidence to point the finger at man. What else could explain the animal's final extinction? Yet again, were its giant antlers implicated? 10,000 years ago, the landscape across Britain and Ireland was transformed once more.
It's so dramatic, it's like a light switch clicking on. And instantly, this landscape is warm, the soils begin to form, and any plant that's close by will suddenly be able to colonise that landscape. So by this point, 9,500 years ago, find a piece of pine wood. There you can see the nice bright red colour in the bark. And right at the very top of the core here is the shell of part of a hazelnut.
Grasslands gave way to forests after the Ice Age. At first, birch, pine and hazel. But by 9,200 years ago, even oak was colonising northern Britain. Ironically, Adrian Lister believes the changing countryside may have brought further problems for the Irish elk.
The kind of habitat the Irish elk liked was lots of open grassy areas where it could graze, but it wouldn't have liked the dense forests that started to grow up as the climate warmed in the present interglacial. Dense forest didn't give it the variety of food, especially grass, that it liked. Also, of course, with those very huge antlers, they would have been an encumbrance in the forest and also would have put the Irish elk under pressure as its preferred habitat shrunk and shrunk.
The warming climate would have sealed the animal's fate. As the ice caps melted, sea levels were rising some 30 feet every 1,000 years. The Irish Sea was created, and new islands like the Isle of Man appeared. The remaining Irish elk were split into small vulnerable groups, literally marooned. This may have had disastrous consequences for the gene pool.
If they're in a situation where they can't easily exchange genes between the populations, then the relic populations may become inbred, and that's not healthy either, especially if they're in a situation where they would need to adapt quite quickly to changing conditions. They may not have the genetic resources to do that.
9,000 years ago, the remaining pockets of Irish elk were on the brink of extinction. It had prospered for tens of thousands of years. But finally, climate change isolated the Irish elk in small populations, struggling in an increasingly forested landscape. Evolution had crafted a highly specialized animal, dependent on open grassland to nourish its extraordinary antlers.
Clearly, the general design and lifestyle of the Irish elk was tremendously successful while the going was good. And they, in a sense, specialized for this high life. And then suddenly, when the climate changes, they're almost locked into this expensive lifestyle and they can't pay the bills anymore.
The case of the Irish elk reveals that, faced with a changing world, too highly evolved a design can actually prove an animal's undoing.
Specialized animals are usually the ones that go to the wall first. The generalists, like the meek, inherit the earth.
In 1930, Tasmanian farmer Wilf Batty had a fateful encounter with an extraordinary creature. What Batty couldn't know was his gunshot didn't merely end the life of a single animal. It marked the death knell for an entire species. The Tasmanian tiger. Tasmania lies 200 kilometers off the south coast of Australia. An isolated wilderness the size of Ireland, it's famed for its supreme predator. A bizarre creature, it had the body of a wolf. And huge jaws, its ultimate weapon. The stripes on its rear earned it the name Tasmanian Tiger. But the most amazing thing about this wolf-like predator is that it wasn't a tiger at all. It was more kangaroo than canine, a wolf with a pouch. A combination which would lead to it becoming one of the most hated and misunderstood animals in history. Ironically, despite its recent extinction, today the Tasmanian tiger is celebrated everywhere on the island. A far cry from the scientific ignorance prevalent while there was still time to save it.
Humans failed at this animal really badly. In particular, scientists failed it really badly. They had the knowledge to save it. But at the same time, deep within themselves, they accepted the idea that extinction was inevitable.
This is the story of an animal that became extinct because humans didn't understand it. It was new to them, and it was different. It was a marsupial.
The whole concept of marsupial inferiority was accepted by scientists. They expected marsupial animals to be weaker, less fit, less capable of surviving, certainly less capable of surviving when Europeans and European animals entered their environment.
During the age of the dinosaurs, marsupials evolved away from other mammals. Isolated in Australia, they developed a unique way of nurturing their young. Instead of growing fully inside the womb, the fetus leaves the mother's body and continues its growth in a pouch. Scientists originally dismissed marsupials like the Tasmanian tiger as primitive and inferior. It's only now, after its extinction, they are studying it properly, using some extraordinary evidence. It died out so recently, amazingly, it was captured on film. For tiger expert Nick Mooney, this is testimony not of an inferior creature, but an extraordinary one.
This tiger was called Ben. We can see the very thick base of the tail and the stripes, very characteristic of Tasmanian tigers. The tiger's walking rather like a dog on its toes, but the pattern of walking is quite different. There does seem an awkwardness, and dogs seem to be more rigid than this animal. This animal seems to have to me, a beautiful fluidity about it when it walks. You notice the animal yawning there. It had the largest gape of any land mammal. They must have had the mother of all bites, these things.
Film footage can tell us about the animal's appearance and behavior in captivity, but it can only go skin deep. Superficially, the Tasmanian tiger may look like Nick's dog, but closer inspection reveals just how much of a remarkable evolutionary mixture this animal really was.
There's some immediate similarity with a dog skeleton, but there's also some really important differences. You notice this tail has very long vertebrae, and it makes the tail very, very stiff, whereas a dog tail is extremely flexible. So looking at the whole skeleton, we have the impression here of an animal with quite a flexible, supple front end. Short vertebrae, and lots of them here. But as soon as we get about halfway down the animal, suddenly the vertebrae become much longer. The other half of it seems to be much less flexible, and in fact, if you cut this in half, you could be excused for thinking the front half and the back half belong to different animals. There's a fundamental change in flexibility from supple to very stiff here. So this is fairly good evidence that the Tasmanian tiger evolved from a hopping ancestor like a kangaroo. As we go forward, the animal seems much more like a dog, a big head with lots of teeth. We have a lot of muscle attachments here to hold that head, a long neck. This was the main fighting end, the main killing end of the animal.
Evolving on opposite sides of the planet, the Tasmanian tiger and the dog adopted a similar design for the same reasons: to chase and kill. But how efficient a predator was the tiger? In the absence of any proper scientific study of the animal before its extinction, this isn't easy to find out. But there is one extraordinary marsupial that might shed light on the question: the Tasmanian devil. DNA analysis reveals that it is one of the Tasmanian tiger's closest living relatives. Devils give zoologist Menna Jones an insight that neither footage nor bones can. First, how it might have stalked its victim.
The tiger was probably not a fast-running predator, not like a wolf. If you look at the skeletal proportions of a tiger and compare these with a wolf and with other marsupial carnivores, they are far more similar to the devil. They had a relatively long foot compared to the thigh bone, and this means they don't run very fast. And the devil doesn't run very fast, but they make up for this with endurance. They can run for a very, very long time.
In the forest, animals are becoming active again after the heat of the day. This mature female is 3 years old. She's made a lair in a small cave, a shelter where she'd be able to rear future cubs. A solitary territorial predator, each day she stalks the forest for prey, her tail stripes helping to keep her camouflaged. Her favourite victims are wallabies, possums and kangaroos. Picking up a scent, she begins her pursuit. Easily pursuing the wallaby for hours through forests, rivers and valleys, her sheer stamina means eventually she'll corner her prey. Now the wallaby is exhausted. It can run no more. But Menno's work comparing devils to the tiger reveals that when it came to eating prey, the two animals were very different. Devils crunch bones like carrots, but the Tasmanian tiger preferred other body parts.
If you look at the lower jaw of a devil, the canine teeth in an adult animal are often broken and they're quite blunt. And most of the molar teeth are also quite blunt. This is because the devil is a bone crusher and it wears its teeth down and it breaks its teeth eating bone. The tiger, even in an adult animal, an adult tiger, has quite sharp canines, they're not broken, and all of the molar teeth remain sharp right through its life. This indicates that the tiger probably ate the soft tissues of the animal, the muscle tissue and the guts, but it probably didn't eat much in the way of bone.
Having crushed and suffocated the animal with her powerful jaws, she uses her sharp teeth to pick out the most tender parts of the kill, the vital organs, the liver, heart and lungs. But despite her successful hunt, the tiger and the rest of her species are living on borrowed time. Its wilderness home was suddenly invaded by the modern world, and the Tasmanian tiger was about to become an object of fear and loathing in the human imagination. The modern history of Tasmania began in 1803 with the establishment of a harsh British penal colony, and some of the earliest encounters with the animal were made by convicts on the run. Convicts often escaped in the forlorn hope they could walk to China or India. Most perished. Some were even forced into cannibalism. One account, written in 1805 after the recapture of two men, describes how they'd returned to risk the cat-o'-nine-tails rather than face what they'd seen.
They informed me that when they were in the wood they saw a large tiger. I make no doubt, but here are many wild animals which we have not yet seen.
This was the first time in recorded history that the animal's stripes led to it being mistaken for a tiger. From that moment on, in the minds of Tasmanians, the tiger became a monster to be feared and killed.
Europeans came from a recent history of having exterminated wolves, lions, every possible predator and dangerous animal, and the Tasmanian tiger suffered exactly that fate.
Yet the precise role humans played in the tiger's demise is still steeped in controversy.
By the end of the 19th century, the Tasmanian tiger is in a lot of trouble. But it's not just the humans out there in the bush and in the farming land which are causing the problem. There's a lot more to the story than that.
By the 1880s, vast swathes of Tasmania had been transformed into pasture to graze millions of sheep brought to the island. This was the beginning of the end for the tiger. Farmers were now on the tiger's hunting grounds, and they were horrified by the discovery of dismembered sheep. Blaming it for the killings, the tiger became their sworn enemy.
In the Tasmanian archives here is this paper trail of evidence about how the animal was hated and feared. Here we have a petition submitted to the government for destroying native tigers. In fact, it reads, "We shall have to abandon the Crown lands occupied by us and give up sheep farming altogether unless some means can be devised for combating this evil." Petitions like this signed by dozens of influential landowners, of course, are very powerful things in the earlier colonial days.
It was this kind of pressure from the farmers which eventually forced the government to act. In 1888, a public bounty of £1 was introduced for every Tasmanian tiger caught and killed.
So this went on, and here's a government voucher to pay Mr. Brooks in 1894 10 shillings for destroying one half-grown native tiger, a full-grown tiger being worth £1.
By the end of the 19th century, the Tassie tiger had been indiscriminately slaughtered, both by individuals, encouraged by the Tasmanian government's bounty, which at its peak, the government was paying a bounty on a Tasmanian tiger once every 2 days.
Ironically, the killing was actually unnecessary.
The losses attributed to Tasmanian tigers were greater than the whole population of sheep. In some districts, like, it was quite absurd. The Tasmanian tiger killed some sheep, without question, but it made the perfect scapegoat for general mismanagement. And that mismanagement often came about because people were farming in very unfamiliar areas using unfamiliar techniques.
But out in the bush, trapping tigers had become a lucrative industry. And it wasn't just money that drove the killing. Continued scientific ignorance also played a part. With no studies of the animal in the wild, no one knew exactly how many tigers there actually were, and no one could judge just how the killing was affecting their survival. As the top predator, its numbers would have always been limited, perhaps no more than 3,000 individuals. As many as 2/3 of these may have been wiped out in the bounty years. At the time, few cared.
People didn't understand marsupials. Europeans didn't really have empathy. We're not marsupials, so there's not that basic empathy. We get on so well with dogs because we're not that different from a dog in our social organisation. They're essentially all very social species, and none of the marsupials were. So marsupials didn't cooperate with us.
Marsupial inferiority provided an excuse to accept what was happening, an excuse for scientists to suggest it was inevitable, to possibly put less effort than they might have into saving the species.
In 1909, the final chapter in the extinction of the tiger began to unfold.
100 or so Tasmanian tigers per year were being killed, and this seemed a fairly steady number. But then the population crashed, and crashed very, very suddenly.
In 1909, the killing rate collapsed from 100 each year to just 1. A drastic fall, suggesting it wasn't only trapping that was destroying them.
It was not persecuted over large amounts of its range, and even if we'd lost all the animals in those settled areas, there still should have been a trickle of immigration from those more remote areas. But the fact is, the population seemed to have radically decreased all over its range in Tasmania. History has shown that hunting and trapping alone rarely drives anything to extinction or even near extinction. So something else happened.
The rapid decline suggests something far more deadly than even humans.
It can only have been a disease, and in fact there were sick and dead animals reported with symptoms rather like canine distemper.
Canine distemper is an airborne virus. The initial symptom is fever before a painful death involving discharge from the eye, diarrhea, vomiting, and seizures. Yet marsupials are known to suffer similar viruses all the time without being wiped out. Why might this outbreak have been so devastating?
Almost certainly, if there was no hunting or habitat loss, the disease would have been of little consequence to the population. We think it was probably a viral pneumonia, something reasonably common in marsupials. But in the fragmented state, the fragile state this Tasmanian tiger population was in, that this disease probably started that last drum roll of extinction.
The female tiger is ready to mate, but hunting and disease means she can't find a male. And she herself is now sick. The tiny wild population can no longer replace itself. Extinction now looms. Yet there was one last chance to save the animal. As the Tasmanian tiger got rarer, it became more and more famous.
To me, it's also ironic that science played, or so-called science, played a part in the demise of the Tasmanian tiger, in that when people realised this animal looked like becoming extinct, there was this mad rush to catch every last one and put it in a zoo or a collection.
By 1930, the majority of tigers known to still exist lived protected in zoos, yet this wasn't seen as an opportunity to save them.
There was no attempt at all to breed them. There was no attempt at all to do something as obvious and as sensible as breeding them in captivity.
Remaining unbred in captivity, most zoo specimens had died by the 1930s, and sightings in the wild were very rare. At last, there were calls for its protection, though still no one recognized that the Tasmanian tiger was on the very brink of extinction. For farmers, it was still vermin to be exterminated. At Wilf Batty's farm, weakened by disease and desperate for food, the female is driven to go after the easiest prey. What Farmer Batty didn't know was that he had just shot the last Tasmanian tiger ever seen in the wild. At this moment, the tiger passed from reality to myth. Still, no one believed the tiger was extinct, and in the years since then, many have claimed to have seen the animal. It's become a sort of Tasmanian Bigfoot or Loch Ness Monster, but no sightings have ever been proved.
A lot of the reports of people seeing Tasmanian tigers, lots of that sort of anecdotal evidence is definitely a reflection of a yearning to have this animal back.
But no one has seen a live tiger for over half a century.
It's reasonable enough to invoke the 50-year criterion, which says there's been no evidence for 50 years that the animal is extinct.
After Batty shot the last wild tiger, the only individual left was Ben, penned up in Hobart Zoo.
I've sat and watched this black and white film many times, and at times it makes me quite angry. There's still people exist now that would probably exterminate it all over again if they had the chance. Not everyone feels guilty about it. There's a lot of people scattered around the world that don't want big predators about.
There were two final twists. Ben had been misidentified. He wasn't a male tiger, and on the 7th of September 1936, she died. Ironically, for her last 59 days, she'd enjoyed full legal protection as an endangered species.